हेलो बच्चों, let's read this question. Hydrogen atom in its ground state is excited by means of monochromatic radiation of wavelength 970.6 angstrom. Different wavelengths are possible in the spectrum, and after absorbing the energy of radiation, hydrogen atom goes to the excited state. And after 10 raised to the power minus 8 seconds, the hydrogen atom will come to the ground state by emitting the absorbed energy. The electron of excited state hydrogen atom is in which of the following energy states? So students, इस क्वेश्चन में हमें एक हाइड्रोजन एटम दिया गया है in which electron is rotating in the ground state, and when electromagnetic radiation of wavelength 970.6 hits this electron, this gains some energy and jumps to some higher energy level, let's say nth energy level. So we have to find what is this nth energy level. So for that, please note the key concept of this question. That energy associated with every energy level is given by minus 13.6 into z square upon n square, and electrons on absorbing exactly the difference of energies of two energy levels jumps to that energy level. So what I am trying to say, students, that electron jumps only if it absorbs same amount of energy, that is the difference of final energy level minus initial energy level. We can write minus 13.6 z square upon n final square minus energy initial 13.6 z square upon n initial square. So taking minus 13.6 z square common, this is 1 upon n final square minus 1 upon n initial square. The value of delta E we can write as Hc upon lambda, because this is exactly that amount of energy which is absorbed from the radiation, equals to minus 13.6 z square into 1 upon n final square. Let's say this is excited from first energy level to nth energy level. I am taking initial energy level as first because electrons were present in ground state. So n final is n square minus 1 upon 1 square. This is n initial. So we can write 1 upon lambda equals to minus 13.6 into z square upon hc into 1 upon n square minus 1 upon 1 square will be 1. So 1 upon lambda equals to minus 13.6. Taking minus into the bracket, this will be 13.6 hc into z square 1 minus 1 upon n square. This term comes out to be a Redbux constant, which is called R, and its value constant is 1.09 into 10 raised to the power 7. This is the atom of hydrogen. For hydrogen, Z is 1. 1 minus 1 upon n square. So students, from here we can write the value of lambda on reciprocating 1.09 into 10 raised to the power 7 into 1 minus 1 upon n square. From here we can substitute lambda. This is 970.6 into 10 raised to the power minus 10 meter. This is 4 angstrom. This equals to 1 upon 9 into 10 raised to the power 7 upon 1 minus n square. From here we can write 1 minus 1 upon n square. This is equal to 1.09 into 10 raised to the power 7 into 976 970.6 into 10 raised to the power minus 10 meter. And on solving, this denominator term will be 1 upon 1.057, and this is 1 upon n square. This is 0.94, and from here 1 minus 0.94, this is 1 upon n square. 1 upon 1 minus 0.94 is 0.06. This is equal to 1 upon n square, and for n square this is 1 upon 0.06. So the value of n we will get from here. This is approximately equals to 16.66. We can assume n square equals to 16. So n equals to 4. This shows that electron was transmitted from ground state, that is n equals to 1, to n equals to 4 by absorbing energy from electromagnetic radiation of 970.6 angstrom. And this matches with option C of this question. I hope आपको ये concept समझ आया students. Thank you.